unless you want to be entertained on YouTube. So we're going to talk about sequences, and today's work and maybe even tomorrow's work, it's more about recognizing patterns. And so a lot of it is gut feel and intuition until about Monday when we start really building rules. C0. We start building rules to come up with equations for sequences. So first of all, a sequence is just a bunch of numbers. Are we taking notes there? Huh? You already got it down? Yeah. You got this down? Okay, you don't want to take down the definition of a sequence? Where? I don't see a definition there. What, the definition of a sequence? You're going to be shitting me. Where? Yeah, there is no definition. So that's what I'm trying to tell you. Definition of a sequence is just a bunch of numbers that have a certain pattern in them. And it's a question of finding that pattern. Okay? It's a question of finding that pattern. So the first sequence here, everybody can see what the pattern is. What's the pattern? Sorry? Well, an odd person would say odd numbers, right? Yeah. Okay, how about the next one? Multiply previous one by 2. Okay, there's another way of thinking about it. Can anybody see another way? Edward? Yeah, see, he's a computer hacker, so he knows what the sequence is, okay? So he's saying that this sequence is 2 to the n, except that, Edward, in this case, n starts out with what number? 0. Okay, so this is an unusual pattern, okay? Starts out with 0, 1, 2, 3, 4, and so on. So n is essentially a position of the number in the sequence. So this is the 0th position, this is the first position, this is the second position, and so on. This is an unusual sequence where we start out with 0. The sequences we're going to see, we will start out typically with n equals 1. Okay? So you guys get an idea about what a sequence is? Okay. Let's talk about how to write sequences. Okay? And there are two different ways of writing sequences. The first one is called a functional form. Okay, it's called a functional form. And by that I mean that it is explicitly a function of n. Hello, can you move up forward, please? Yeah, come move forward. Yeah, permanently, that's your seat. Oh, is Adam not here today, right? Okay, so look, you need to be moved somewhere else, and I'll have to think about where to move you. Yeah, this is a great moving class. Yeah, great moving class. Okay? It's an explicit function of n. So the first term, n is 1, so a sub 1 is equal to 2. Jafar, the second one would be a sub 2, and what would that be? He's got the answer. Right there, look at him. 4. But he can't see, so you're going to say it out. 4. Jafar, how about a sub 20? 40. Okay. So evaluating a sequence that is explicitly in the function form is pretty easy. You just plug in the value of n, and you get the number in the sequence. Okay. All right. Are you texting or are you doing your calculator? 2 times 20 is 40. Yeah. Or are you texting someone to find out what the answer is? Okay, how about next one? You guys work on this one, okay? Okay? So minus 1 to the 20th power is going to be 1. Anytime you have an even power there, it'll become a positive quantity. Okay? So then this would be 2. So in words, how would you describe this sequence? In words. Not in math, but in words. How would you describe the sequence? Anybody? Zubair? Sorry? No, in words. How would you describe it? Don't tell me what the sequence is, but in words, how would you describe it? Sorry? Yeah, but I think it's amount. No, someone was saying odd, right? Didn't someone say odd? I thought I heard someone say odd. Odd numbers. Right, in words. Okay. All right, is everybody okay? All right. Okay, so on this one here, I want you to kind of develop this. So I want the functional form for this sequence. This is kind of a little tricky, okay, so I might have to give you some prompts on it. So the first thing you want to do in finding out the equation for a sequence is put down the values of n. Okay, so n is 1 here, it's 2 there. Edward, you've got to be quiet on this one, okay, because this is like one of your binary patterns. Okay, so I'm giving you a hint there. And I will also give you a hint that it is 2 to the something. So you've got to stop here and think a little bit. Okay, because if you look at this, you know that this is 2 to the 5. This is 2 to the 6, 2 to the 7, and so on. So right here, you're adding 4 to n every time. So then this becomes 2 to the n plus 4. Is everybody with me? Again, you can see that there's no formulaic way of really finding the answers to this. Okay, it's some of it is really gut feel, and some of it is with great facility with numbers. Okay, if you know your numbers really well, then this becomes easy. All right, next problem. Okay, I want you to do this entirely on your own. You want to think about the numerator and the denominator as separate sequences. So in the numerator, you're going to get some function of n. Denominator, you're going to get another function of n. So try and develop that, okay? Try and develop that. Okay, then there's another way of writing. You want to put that away, okay? Because otherwise I'll take it away. You're sitting right in front of my fucking nose and you are texting. That's not nice. Put it away in your bag. Okay, and that's really rude. Okay, so there's another way of writing a sequence, and that's called a recursive sequence. Okay, so take this definition down and then I'll go over it. Emily, you need to put that phone away too. Oh, Tanish. I don't care. Put it away. Put it away. All right, so here's a recursive sequence, okay? This is actually a very famous sequence called Fibonacci sequence. And notice that it's not like any of the other sequences where we wrote it down explicitly or in functional form. In other words, it's not of the type 2n plus 3 over 6n minus. It's not of that type. In other words, it doesn't explicitly depend on n. Okay? So instead what it's saying is to get the nth term, you add the previous two terms with the condition that a sub 1 equals 1. Okay? That's kind of given to you right there. Then to get a sub 2, you're going to put in 2 for n here, and you're going to put it there and there as well. Oops, actually I should say you want to put actually in the Fibonacci sequence, 2 of the terms are given to you. The first 2 are given to you. Okay? And A2 is also given to you as well. So the first 2 terms are given to you. So to get the third term, okay, you're going to put 3 in here, which is equal to a sub 1 plus a sub 2. Okay? Which is going to give you a sub 1 plus a sub 2. 2, which is right there. That's your third term in the sequence. Okay? So the Fibonacci sequence is kind of different in the sense that you need to be given the first 2 terms before you can even write the third term. Okay? Now the very difficult thing in this sequence, in the recursive sequence, is that say the sequence goes on and on and on, and I want to write the 50th term. Okay? It becomes really hard because to get the 50th term you need the 49th and the 48th. To get the 49th you need the 48th and the 47th. So you can see that it becomes extremely difficult computationally to do that. Okay? But there are ways of actually taking a recursive sequence and putting it in functional form. We don't particularly learn that in this course. Okay? All we learn is how to find out values of the terms in a recursive sequence. So let's take a look at the next sequence here. Okay? So here's your sequence. Okay? It's given to you in recursive form. That's a recursive form. Why is that called a recursive form? Why is that called recursive and not functional? Sorry? That's right, because if you really look at the relationships there, it's not a function of n explicitly. Okay? It's a function of a sub n. In other words, it depends on a previous term. It doesn't just have to be the previous term. It can be a bunch of previous terms. Okay? It could be a bunch of previous terms. And for the recursive sequence, I'm given that a sub 1 is 25. In other words, I'm given the first term. Okay? So then to get the second term, which is this one here, I put n equals 2 in this equation here, in this one there. A sub 2 is equal to, sorry, I put 1, a sub 2 is equal to a sub 1 minus 5. Okay? And I know what a sub 1 is. 25 minus 5, that gives me 20. And then in order to get a sub 3, I'm going to go a sub 2 minus 5. Okay, which is going to be 20 minus 5, which is 15, which is this term here. Okay? Chris, you with me on this? Now this sequence here, I'm going to erase some of the stuff here, okay? This sequence here can be written as a functional form. Can you guys spend a minute writing that as a functional form? In other words, I want a sub n to be a function of n. So spend a minute doing that. Writing these sequences down. Does anybody remember from Algebra 2 what sequence this is? Pasa, you said you saw this in Algebra 2, so tell me what you saw in Algebra 2. What is this sequence called? The one that you see up there, dude. It's the same sequence. There's only one sequence, man. That one. Anybody know? In Algebra 2, you studied 2 kinds of sequences, or you should have. Wow, Fibonacci is in it. Yes. Which one is this? Sorry? You said geometric, so it's the opposite. It's arithmetic. Okay? It's an arithmetic sequence. Okay? And we're going to learn that formally on Monday and Tuesday, okay? All right. All right, N box. So you need to get your graphing calculators out. So today we learn the 4th mode of this graphing calculator. Okay, so we've done func, we've done PAR, we've done POL. We're going to do SEQ, stands for sequences. Okay, so put your graphing calculator in SEQ mode, and then if you go to y equals, shows up entirely differently. Okay. So for the TI-84, it wants the smallest value of n that you're going to start out with. In our case, we are starting out with 1. Okay? So n min, which is the smallest value of n, it's going to be 1. U sub n is the equation that you see for the sequence. In this case, it is 2 minus 4 over n. And for some strange reason, this calculator wants to know what the very first term in the sequence is. Even though you give it the formula, you give it the n min, it still wants you to enter what that smallest value of u is. So if you put n equals 1 in here, okay, put n equals 1 in there, it becomes 2 minus 4, which is a negative 2, which is what you enter in your calculator there. Okay, that's what you enter in the calculator there. So everybody with me on that? Sorry? I think it automatically does that, I think. Yeah, it already gives you the curly braces. And then if you go graph that, you should see a bunch of dots. You should see a bunch of dots. Why is it a bunch of dots? Well, there's some people, I got to tell you the story in period 1. So period 1, Zach is complaining that his calculator is not giving him dots, it's giving him a line. So guess what I ended up doing to his calculator? He told you? He's really mad with me. But hey, I mean, why do you have your notes in there, man? That's messed up. That's messed up. Oh my God. Yeah, that's messed up. That's messed up.
No, but then, did you hear about his stats model? He thought he would fill it, and then he filled it, and then he cracked off the book.
Semester 1?
But he
Okay, so explain to me why this is a bunch of dots and not a connected line. Anybody can explain to me? Yeah, Shwarya? Yo, guys, pay attention here. Exactly. In other words, on the horizontal axis, what's the variable on the horizontal axis? N. What's the variable on the vertical axis? U. Go back to this. Go back to this. Okay, U is on your vertical axis. Remember, it used to be Y1. Okay, it's not Y1, it's U. And the horizontal axis is N. And N is always going from integers. It's either 1, 2, 3, 4, 5, and so on. Not any fractional numbers. Okay, that is why it's a bunch of dots. You guys okay on that? Yeah? Chris? Okay, I think that's it.